The question is, informal settlement houses, how can we apply GEAR's research to those structures? So looking at not only your structures of lesser proper construction, but something like a mud house, for example, which currently in the regulation has a PPV limit of 6. So I know you cringe when you hear PPV, but yeah, that's the question that's tabled. So if you can maybe walk us through how GEAR's research can become applicable so that we can actually practically apply it to, for example, informal settlements. Thanks.
Is the microphone working?
You sound okay.
Yeah, sound okay. What a shame. Okay, well, that's obviously a really good question. So let's start with the mud question. I think that's really good. Really interesting to see, obviously, that in your standard. We've got geotechnical engineers in here, haven't we? So I've got a home crowd. So let's start off with geology and geotechnics. We have mud on the floor. You blast. Before we do any science, and I think this is what I want to kind of draw out, just think of your relatable parallels that you've got. You've got life experience. You'd see blasting. You know the vibration go through the ground. So when you're walking towards a blast, and if you're walking over any mud, just have a think, how many crevasses and massive cracks have you seen in the mud as you walk towards your blast? That's your first bit of scientific evidence on here. So I think from my point of view, I'm certainly not an expert on it, but I would say that your geotechnical engineers in the room fully understand soil mechanics. Now, if we understand soil mechanics, we can actually apply soil mechanics straight to your building structure. So let's go from that lesson. I'm going to start off with the assumption that when you walk away from your blast, you know what kind of PPV is close to your blast. We are not seeing damage within the mud. So as a material and response to the material, we understand it has actually innate strength, which is why you can build houses out of it. So the next aspect of this is then thinking about how we apply geotechnical engineering to it. So again, your engineers out here will understand we've got drained and undrained strengths. But with the mud house here, we're actually dealing with undrained mud that we can properly catalyse, we can properly put engineering through. So all you're then saying is, well, if we understand the undrained strength, which is actually very high, we can actually put a seismic coefficient against that to determine the point of failure. So it's quite a relatively straightforward hand calculation. So to answer the rest of the question, it's all related. So the original testing done on damage to properties is all about damage to plaster. It's not damage to the whole structure. So if we're setting a cosmetic damage point, we are not really interested in how well the house is built.